Namaste and welcome to the tutorial on problems on Gram-Schmidt orthogonalization process part 2. In this tutorial, we will discuss about how to construct the orthogonal basis with integer coefficient for the polynomial. So, let's start with the problem. Let V be the vector space of polynomial f of t with the inner product of f and g, which is given over here. Apply the Gram-Schmidt orthogonalization process to this set to find the orthogonal basis of the set with the integer coefficient for the polynomial t3 of t. This problem statement is a solved problem in the Schaum series, linear algebra. So let's discuss this problem. Here we will use a simplified rule for this integration. We state that if the powers of this inner product r plus s is equal to n, then this integration is reduced to 2 by n plus 1 if n is even, and it becomes 0 if the n is odd. If you observe, the integration is having the limit from -1 to 1. So by using this rule, we will further solve the problems. So now, before proceeding the problem, we will just consider that this given set, that is 1 comma t square comma t cube, is the given set to us, that we will equate to this set of the linear independent vectors, and similarly the set of the orthogonal basis that we have to find, we will equate it to the terms w1, w2, w3, w4, so as it will simplify our understanding how to use the Gram-Schmidt orthogonalization process if the polynomials are coming into the picture. So let's start with the step 1, in which we have set the step 1 of the Gram-Schmidt orthogonalization process, in which we set w1 is equal to x1. So here w1 represents f0 and x1 value is 1, therefore the value for the f0 becomes 1. Similarly, step 2, we have to compute this factor as per the Gram-Schmidt orthogonalization process, and by substituting the values of these terms in this factor, that is the x2 w1, we get this factor is equal to t, as x2 over here is equal to t, and the value of w1 as we have set over here is a x1, that is nothing but the 1, and that in terms of f is the f0. So therefore this terms becomes the t. Now we will set this term as in f1. So the values of f0 and f1 can be calculated by, as I have shown over here. Now we will proceed further for the calculation of next terms. As per the Gram-Schmidt process, this is the term that we have to calculate in the step 3. As we have already set what will be the x1, x2, x3, x4 for us, and similarly what will be w1, w2, w3 and w4 for us in terms of the given values in the problem statement, we will substitute the respective values for the x3, w2 and w1 in this equation in the form of the given set, and therefore this term we can rewrite for our polynomials as in t square minus t inner product of t square with f1 divided by the inner product of f1 with itself multiplied by f1 minus inner product of t square with f0 divided by the inner product of f0 with itself and multiplying this whole term with the f0. This term we obtain by substituting the respective values of x3, w2 and w1 as we have found in the previous steps. So by substituting the values of these terms, like f1 is t over here and f0 we have found as in 1, and therefore this equation becomes as shown in the equation A. Now we will use the rule that we have considered at the beginning to find out the inner product of the t with two different powers. We can use this formula. So we will consider every inner product term one by one, and hence the inner product term t square with t becomes 0 as the power of the addition of the power of t is odd, and therefore the inner product is 0. Here the power of the sum of the power of t is equal to 2, which is even, and therefore the inner product of t comma t is 2 by 3 by using this formula for the if n is equal to even. And similarly we will calculate the rest of the terms, and by substituting these terms in the equation A we get the value for this term as in t square minus 1 by 3. Now clearing the fractions, we will of the above result we will set f2 is equal to 3t square minus 1 after clearing the fractions of this term. Now we will proceed further for the calculation of f3. For that we will consider this term as per the Gram-Schmidt orthogonalization process, and by substituting the respective terms which are given to us in the problem statement for the x4, w3, w1 and w2, we can rewrite this term in the form of, in the terms of t3, tq, f2, f1 and f0. And by using our rule that we have discussed at the start of the answer, we can compute every single inner product as shown over here. So the inner product of t cube with t3 with 3t square minus 1 is equal to 0 as the sum of the powers of these terms of t terms is odd. Over here the sum of the powers of the term t is even, and therefore we have the calculation as 2 by 5. Here also the summation of the power of t is equal to 2, and therefore it reduced to 2 by 3 by using this rule. Here the inner product of the term 3 with 1 becomes 0 because the summation of the power of t over here is equal to odd number. So by substituting these values in the equation B, we get t cube minus 3 by 5 of t. So over here, by clearing the fraction of the above result, we can set f3 is equal to 5t cube minus 3t. So therefore, these are the required orthogonal bases. As they have asked us to find out only orthogonal bases, that's why we will stop over here. If suppose the orthonormal basis is supposed to be found, then simply you will divide these terms by their norms. So you will divide f0 by its norms to get normalized value for the f0. Similarly, the other terms, other vectors, you can normalize to get your orthonormal basis. Thank you.